All right, this section is solving equations. So you have had this before. This should be a review. So what we're going to be doing is solving algebraically. We're going to find all real solutions, and we're going to check for extraneous solutions when necessary. So extraneous solutions means that you do everything right when solving, but when you plug it back into the equation, it doesn't work. Now, when necessary means that you really need to check it when you have a variable in the denominator, or when you have a variable in a radical, or a variable in an absolute value. Okay, so those are the times that we're going to need to check for extraneous solutions. Okay, so those are 3 times today. So the first one here, when we're solving, what we want to do is we want to simplify both sides and get x by itself. So we have 8x, we're going to distribute our negative, so minus 2x minus 1 equals 3x minus 10. So 8x minus 2x, that's going to give us 6x minus 1 equals 3x minus 10. All right, then I'm going to move my 3x over here. 6x minus 3x is 3x. And then I'm going to go ahead and move my 1 over here. So that's going to give me a negative 9. And then I'll divide by 3. So x is going to equal negative 3. All right, and so there's no fractions, no absolute values, no radicals, so we should be good on that one. You can always plug it back in and check it to be safe if you want to. Now, here we do have fractions. However, x is not in the denominator, so you should be okay. We shouldn't have to worry about any extraneous solutions on this one. Now, when we do have fractions, I like to clear out my fractions just to get rid of them so we're not having to work with them. So the key to doing that, look at your denominators and think of a number that 2 and 4 both go into. So they both go into 4. Whoops. So we're going to multiply both of these by 4. And so, or multiply, sorry, everything by 4. So 1/2 times 4 is 2. And you still have the x. And you have to multiply everything. You can't just multiply the fractions by the 4. You got to multiply everything. 4 times 4, or negative 4, is going to be 16. And 3/4 times 4, the 4s are going to cancel out, so you're just left with 3. Okay, so now we're ready to solve. I'm going to subtract the 2x, and we'll get negative 16 equals x. Okay, so now on C, so we have 2 over y plus 4 over y equals 3. Now, this one we do have to worry about extraneous solutions. So on this, remember, you can't divide by 0. Okay, that's something you just can't do. So on this case, y cannot be 0. So we just make ourselves our note in the beginning that, so if we get 0, our answer, like 0 would be extraneous, and our answer would be no solution. So since we do have the same denominator, we can add 2 and 4, which will give us 6. 6 over y equals 3. And then what I'm going to do is I'm going to multiply by y. This will cancel out. I'll multiply this side by y. And I'll get 6 equals 3y. And then I will divide by 3. So that will be 2 equals y. And we said it couldn't be 0, and y is not 0. So we are okay. That is okay to be our answer. So the only thing y couldn't be was 0, so we're good. All right, on this one. Now, you've got to simplify everything before you start combining. So get rid of all your parentheses. So x times 2x is 2x squared. And then x times 3 is 3x. Okay, over here, you got to multiply. So I like to do FOIL. Remember, FOIL, first, outer, inner, last. So 2x times x is 2x squared. And then 2x times negative 4 is going to be negative 8x. 1 times x is 1x. 1 times negative 4 is negative 4. So this side is going to stay the same. I have some more simplifying to do over here on the right before I can start combining some stuff. So I have 2x squared, the negative 8x, and the x is going to be negative 7x. And we get the minus 4 there. Okay, so if I start combining, if I subtract the 2x squared, well, what happens there is those are going to cancel out. So I'm just going to go ahead and mark that out. And I'm going to go ahead and add my 7x over here. So that's going to give me 4x equals negative 4. And then I will divide by 4. So x equals negative 1. Okay. All right, so on E, okay, so we have fractions. We have a variable in the denominator. So we take that x minus 3, set it not equal to 0 because we're worried about what x can't be. Because remember, the bottom can't be 0. We can't get x where something is going to give us a 0. So if we move this 3 to the other side, x can't be 3 because if it's 3, it's going to give us a 0 in the denominator. So if we get that for an answer, that's going to cause us issues. Okay, so we start solving. Now, we don't have like common denominators here. So you've had this in math 2, you've had this in math 3, you might be a little bit rusty. But there's a process we go through here where we find our least common multiple. So our first denominator is x minus 3. We don't have a denominator for the 3 there. And then we have a least common multiple of x minus 3 there. So those are what's in common. So we have a least common multiple of x minus 3. Now I go through a process of where I look at each part here. So like our first fraction has the x minus 3, okay? Which means I don't have to multiply by the x minus 3, so it doesn't change. Now my second part, the 3, it's missing the x minus 3, so I'm going to multiply by it. Then my last part of the fraction has the bottom here, it has the x minus 3, so it's not missing anything, so I don't have to multiply by it. So what I'm going to do now is I've got everything set up, and I'm only really worried about the top part because I've set it up that way. So when I look at that, I've got x plus, and I'm going to distribute the 3, 3x minus 9 equals 3, okay? And so x plus 3x is 4x minus 9 equals 3. And then if I add the 9, I'll get 4x equals 12. I'll divide by 4, and so x equals 3. Now remember, oops, I forgot my not equals up there. So remember, we said x couldn't be 3. So this is an extraneous solution, okay? So that means even though we did everything correctly, it doesn't really work. So this is no solution. That's our symbol for no solution. So that's not going to work. Okay, we have another fraction, or a problem with more fractions. So again, we need to do the same thing. Now, what I like to do, I see this is a difference of squares. So I'm going to factor this out. X plus 2, x minus 2, x plus 2, x minus 2. I'm going to write that out as the factored form. So I know x can't be a negative 2 and x can't be a positive 2, because if it's those things, it's going to give me a 0 on the bottom, okay? And I simply got that by saying like x plus 2 can't be 0, and I subtracted the 2 to the other side, and the same thing for the x minus 2. Can't be 0. So like if you move the 2 to the other side, you'll get negative 2. If you move the negative 2 to the other side, you get a positive 2. So that's where that's coming from. Now, again, if I do find my least common multiple, if I write each denominator out over here. So if I pair up or triple up everything, my least common multiple is x plus 2, x minus 2, okay? So if I look at my first part, it has everything that my least common multiple has. So I don't have to multiply my first fraction by anything. My second part, the 4 over x plus 2, x minus 2, it has everything the least common multiple has. But now the 1 over x plus 2, it's missing the x minus 2, okay? So now, again, just a little shortcut here, I'm only worried about the top part. That's why we kind of multiply, so we can just focus on the top part, and it helps us solve. So when I write out, I have 2x equals 4 minus, now I'm going to write this out instead of multiplying, just because it's a negative, and I want us to focus on that negative because I don't want us to miss it. So now if I distribute that negative 1 minus x plus 2, and then 4 plus 2 is 6, and if I add x, I get 3x equals 6, divide by 3, so x equals 2. And again, we said that x could not equal 2, so the 2 is extraneous. So our answer is no solution. All right, moving on to G. Now, this one is going to have to be factored, okay? We can't just move the 8 over, divide by 4. It doesn't work like that. Anytime you see different powers, you're going to have to factor to solve. So I can factor out a 4z squared, which is going to leave me with z minus 2 equals 0. Okay? Now, set each factored part equal to 0. Okay? So now when we solve for this, divide by 4. So z squared equals 0. And then take the square root. Typically, when you take the square root, you know, you have a plus or minus, but 0 can't be plus or minus, so z is just going to be 0. Here we add the 2, so z equals positive 2. And on this one, we have 2 answers. All right, on this one, again, we have fractions. So if we look at what x can't be a positive 3, x can't be 0, and then, of course, that last fraction there, x and x minus 3, it would give us the same thing. So if I look at my least common multiple, I have x minus 3, I have x, and then x minus 3. So if I kind of pair up what I have x minus 3. Okay, so my first fraction, it's got an x minus 3 on the bottom. It's missing an x. I'm going to stick it there like with my 4. My second fraction, 3 over x, it's missing the x minus 3. My last fraction, it has everything that the least common multiple has. Okay? So again, we are just focused on the top. It gives us a shortcut there. So I have 4x, x minus 2, plus, now since this is a positive, I'm going to go ahead and distribute that 3. 3x minus 9 equals negative 3. I do need to distribute my 4. Okay, so now what we're going to do is we're going to distribute our 4x. So we'll get 4x squared minus 8x plus 3x minus 9 equals negative 3. So I have 4x squared. I'm going to combine the 8x and 3x, give me negative 5x. And I'm going to go ahead and add this 3 in here, which gives me negative 6 equals 0. So I got a factor here. And I'm going to do my slide divide bottoms up method. So 4 times negative 6 is going to give me negative 24. And then I have my negative 5 on the bottom. So 2 numbers that multiply to give me negative 24 and add to be negative 5 are going to be negative 8 and positive 3. So x minus 8 and x plus 3. And remember, you divide by 4. So 8 divided by 4 is going to be 2. And then this is going to be bottoms up. So that will be 4x plus 3 equals 0. So remember, when you're factoring to solve, you set each equal to 0. So if we add 2, x is going to equal a positive 2. And then if we subtract 3 here, 4x equals negative 3, divide by 4, x equals negative 3 over 4, and then we check what it couldn't be. It couldn't be 3 or 0. I forgot my not equal sign again. So it couldn't be 3 or 0, so both of these are good. Okay, so moving on. Okay, absolute value. Now, you want to make sure that this is isolated before you start your problem. So we've got to add our 1. So absolute value of 1 minus 4x equals 5. Now, we're going to set up 2 problems. 1 minus 4x equals 5. And 1 minus 4x equals negative 5. And we'll just solve our 2 problems. Now, again, we got to check for extraneous solutions. So we subtract 1, we'll get negative 4x equals 4. Divide by negative 4, so x equals negative 1. And subtract by 1 here, negative 4x equals negative 6. Divide by negative 4, reduce this fraction. A negative divided by negative is a positive, and that's going to reduce to 3 over 2. Now, if we check, we're going to plug back into our original. So if I'm just checking here, I'm doing absolute value of 1 minus 4 times negative 1 minus 1, and I want to make sure that that equals 4. So that's going to be 1 plus 4, which is 5, because the 2 negatives are going to be positive. So that's going to be 5 minus 1, which is 4. And then I'll do the same thing here. So 1 minus 4 times 3 over 2 minus 1. And so that's going to be 6. 1 minus 6 is negative 5, but the absolute value of that is going to be 5. 5 minus 1 does equal 4. So both of these work. So we are good on those. Okay, so on J, notice our absolute value is isolated, so we are ready to go ahead and set up our 2 problems. 1 to the positive, 1 to the negative. Now, notice we got the 2 different powers, so that means you need to move the 3 over, and we're going to have to factor to solve. So we got to think of 2 numbers that multiply to be negative 3 and add up to be negative 2. So that's going to be negative 3, positive 1. All right, then so we are going to set each equal to 0. And we're going to add 3, so we'll get x equals a positive 3, and then we'll subtract 1 here, and so x equals negative 1. So again, we want to check and make sure that they work. So if I plug in 3 squared minus 2 times 3, so that's going to be 9 minus 6. That's going to be 3. Absolute value of 3 is 3, so that one works. And then if I do negative 1, now be careful here. You're squaring negative 1. So if you're typing that in your calculator, make sure you do put parentheses around it. Minus 2 times negative 1. And this is, both of these are absolute values. So if you square negative 1, you get positive 1. Negative 2 times negative 1 is positive 2. So we got 1 plus 2, which is 3. So both of these work. Okay. So same thing over here. We have to move our 3 over. All right, so we're trying to think of 2 numbers that multiply to be positive 3, but add to be negative 2. Well, the only kind of numbers that multiply to be a positive number are 2 negatives that would add to be a negative. So that would be negative 3, negative 1, but those don't add up to be negative 2. So this is prime. This can't be factored. We could do quadratic formula on this, but that's not going to give us, if this can't be factored, that's not going to give us like whole numbers for this. So this isn't going to work out for that. So we're done with as far as that goes. So those are our only two answers that are going to work for that. Okay, so for K, okay, so we got a square root problem, radical problem. So make sure it's isolated. This one is. What we're going to do is we're going to square both sides. We want to get rid of the radical, and that's going to be 2x minus 1. 1 squared is 1, and now we solve. So we add 1. We'll get 2x equals 2. Divide by 2, so x equals 1. Now, we still want to check for extraneous solutions. So if I plug in, I've got 2 times 1 minus 1. So that's going to be 2. 2 minus 1 is 1, and that equals 1. So that works. All right, so for L, now I've got the cube root. You've got to get this isolated, though, before you start solving, so I'm going to subtract 1. So I have the cube root of x plus 2 equals negative 1. Now, normally square roots can't equal a negative number. And if this was the case, you would stop. You would say no solution. But cube roots can. Because a cube, it's okay because odds can be negatives. Or odd powers, you can get negatives. So we cube both sides to get rid of that radical. So we get x plus 2, and then if you cube that, negative 1 times negative 1 times negative 1 is still going to be negative 1. So if I subtract 2, I get x equals negative 3. And again, we want to check our answer. We're going to plug back into the original problem. So I have negative 3 plus 2 plus 1. I want to check and make sure that that does equal 0. So that's going to give me negative 1 plus 1. Well, the cube root of negative 1 is negative 1. And that does equal 0. Because I can take a cube root of a negative number. So you can take odd roots. So you just can't take even roots. Okay, on M. All right, so it is a square root, so we need to square both sides. So that gets rid of the radical. Now, we have two different powers, so we need to move everything on one side. Now, I always like to leave my squares positive, so I'm going to move everything over to the right. So I'll get 0 equals x squared. If 5x moves over to the right, it's going to be negative, and if 4 moves over there, it's going to be positive. So when I got a factor, so two numbers that multiply to be 4 and add to be negative 5 are going to be negative 4, negative 1, and I will set both equal to 0. So if I move 4 over, it's going to be positive, and if I move 1 over, or negative 1 over, I should have said negative 4, and if I move 1 over, it will be positive. And if I check both of these, so 5 times 4 minus 4, so that's 20. 20 minus 4 is going to be 16. And square root of 16 is 4. And I plugged in 4, so that works. And then the square root of 5 times 1 minus 4, I want to make sure that that equals 1. So that's going to be 5. 5 minus 4 is 1. Square root of 1 is 1. So that works. Okay, N is an interesting one. Okay, when you have one like this where it has two radicals and a number, what you want to do is you want to put a radical. You always want to split up the radicals. So even though there's this number over here, you want to put this radical over here with this number. So we have, it's going to look like this now. Okay. Now what we want to do is we are going to square both sides, and it's going to almost get rid of our squares. But when you square it, you have to square the whole thing like that. Okay. So now what it's going to look like is this. This square is going to go away. It's going to look like that. This one's going to look like this. Now, I'm going to teach you a little shortcut here. Remember this little saying, some stars don't always shine. It's going to help you kind of shorten this a little bit, shorten this process, because you're still technically doing FOIL with this. I mean, still technically you're doing this, where you have to do first, outer, inner, last. But Some Stars Don't Always Shine is going to kind of give you like a little bit of a shortcut. Okay, so the first S means you square the first. You're going to square 1. 1 squared is just 1. Second S means same sign. So it's a minus. We keep a minus. Okay, the D is the hardest part. Okay, double the product. Okay, so take the product. You're going to take the 1 and the x square root of x plus 2. 1 x plus 2. That's the product. Double it. Well, if you double it, it will be 2 x plus 2. Okay, so that's 2 x plus 2. Okay, the A, Some Stars Don't Always Shine, the A stands for always plus. All right, and then square the last. Well, this is the last. Well, if you square that, that just means the radical goes away. Okay, so that kind of eliminates the whole FOIL process is what it does. Okay, so now combine like terms. So we have, this side is still going to be 3x plus 7. You have the 1 plus 2, that's going to be 3, plus x. I'm going to put that x up there, minus 2 x plus 2. Now remember, this 2 is attached to this, so you can't combine that 3 and the 2. Okay, now what we're going to do is I'm going to subtract the 3 from the 7. That's going to give me 4. And I'm going to subtract the x from the 3x, which is going to give me 2x. And I have negative 2, x plus 2. Okay? So now we still got to get rid of this radical. I still can't do anything with that negative 2, but what we're going to do again, we're going to square it again. Okay? So if we square this again, what happens on this side? If you square the negative 2, it becomes a 4, and that becomes x plus 2 because the radical goes away. Okay? Now, again, if you square that, so you're still doing 2x plus 4 times 2x plus 4. Okay? But remember that shortcut I just taught you, Some Stars Don't Always Shine. Okay, you can do FOIL, or you can kind of remember that shortcut. Square the first, 4x squared, same sign, double the product. Well, the product of 2x and 4 is 8x. If you double that, you get 16x. All right, then always plus, and then square the last. Well, the last is 4. If you square it, you get 16. And it just helps kind of eliminate that middle step is what it does. Okay, well, now I need to do 4x plus 8, and I need to rewrite this. Okay, well, I can see that I've got 2 different powers here, which means I need to get everything on one side, and I'm going to have to factor. So I need to subtract the 4x from the 16x, which is going to give me a 12x right there. I need to subtract 8, which is going to give me a positive 8. So 0's over here. The 4x squared didn't change. Okay, now that means we got to factor. Remember, don't just jump into slide divide bottoms up. Always look for GCF first. I can pull out a 4, which is going to leave me with x squared plus 3x plus 2. Okay, so now I've got my 4 there. 2 numbers that multiply to be 2 and add to be 3 are 2 and 1. So the 4 does not have an x with it. So there's no point in saying 4 equals 0. You don't have an x. You don't have anything to solve. So we just need to do x plus 2 equals 0. X plus 1 equals 0. So x equals negative 2. X equals negative 1. Okay. We have to check for extraneous solutions because you have a radical here. Okay. So I've got negative 2 and negative 1. Let me go back up to the very beginning. So negative 2, 3 times negative 2 plus 7 plus negative 2 plus 2 equals 1. All right, so that gives me negative 6 plus 7, that's going to be square root of 1, plus 0, square root of 0 equals 1. Well, that's going to be 1 plus 0 equals 1. That one works. I can box this one. Okay, so now I need to plug in negative 1. Square root of 3 times negative 1 plus 7 plus negative 1 plus 2 equals 1. So negative 3 plus 7, that's going to give me 4 plus 1 equals 1. Well, that's going to be 2 plus 1 equals 1. Well, that does not work. This one is extraneous. So I could not enter negative 1 as one of my answers. The only one I would enter is negative 2. Okay, last one. All right, so I see that I have a fraction, and I see that I've got two different powers. So I need to get everything on one side, and I want to get rid of my fraction. So you can do one or the other first. Let's go ahead and get rid of our fractions. My only denominator here is a 3. I'm going to multiply everything by 3. So 3 times 2/3 is going to be 2. So I got 2x squared. And then 3 times 2x is going to be negative 6x. And then 3 times 3 is going to be 9. Now I'm going to move my 9 to the other side. So minus 9. And if I try to factor that, if I do slide divide bombs up, I'm going to go ahead and tell you that it does not work. So we're going to introduce quick review on quadratic formula. You need to know it. You've had it, math 1, math 2, math 3. You need to know it, study it, make sure you have it memorized. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So you use quadratic formula when it can't be factored, okay? So here is a, b, c. A is always your number with x squared. B is always your number with x. C is the number that doesn't have any x's with it. So when we plug it in, we have x equals negative b, which is negative 6, plus or minus negative 6 squared minus 4 times a, which is 2, times c, which is negative 9, all over 2 times a, which is 2. So when I simplify this, the double negatives become a positive, plus or minus. Okay, so 6 squared, that's going to be 36, and then minus 4 times 2 times 9. So that's going to give me 108 over 4. Now, when I simplify 108, I got to think of two numbers that multiply to be 108, where one of them is a perfect square. So that is 36 times 3. The square root of 36 is 6. 3 stays in the radical. All right, and then that's over 4. If I reduce this, all of these numbers here can be reduced by 2. So if I'm reducing this, and if I'm leaving this as a reduced radical, 6 divided by 2 is 3. Okay, so both those are 6's. I leave that radical 3 alone. 4 divided by 2 is 2. Okay, now if I do want to change this as a decimal, I would just type this in my calculator. You do it. You do 1 is a plus, 1 is a minus. So like 3 minus 3 times the square root of 3 divided by 2, which would give you negative 1.098. Round to however many decimals we tell you to. Make sure you are typing this in your calculator to make sure you can get this decimal. So again, you would type in 3 minus 3, square root of 3, and then I would just hit enter and then divide by 2, and then do 3 plus 3, square root of 3. You can hit times in there, or you can just hit the square root of 3. It doesn't matter. Hit enter and then divide by 2 to get you a positive 4.098. So whether it gives you decimals, it may give you one or the answer. So either this one or this one, depending on which kind of answer it wants. All right. And so that will conclude solving equations.